Hello, Year 8. Hope you enjoy those two videos, the demonstrations of convection. It gives you an idea of what it actually looks like in real life. Now let's go through some of the theory, right? Use a different colour today. We use blue. Our title, Convection, is important to realise that convection, pause the video obviously and write the notes when you can in your book, only happens in fluids. When we say fluids, we mean liquids and gases. Now, we looked at conduction, the heat transfer through solids last week. So this is talking about convection, which only happens in fluids and gases. We can call a gas a fluid because the particles are able to move and flow over each other. Now we need to get this concept of density really clear in our heads when we're understanding convection. Now density, this diagram illustrates it quite well. It's a good idea to get these two diagrams in your book. And the definition. The density depends on the number of particles in a given volume. So we can see the two volumes here are the same. The one on the left, however, higher number of particles. The one on the right, there's a lower number of particles. So the one on the right has a lower density, we say. And this is a really important note and helps us understand how this particular bit of air might interact with each other, with a low density bit of air and a high density bit of air. Okay, and this is really important in understanding weather systems as well. But we'll cover this theory here. So now we look at these two diagrams. We know what low density is, we know what high density is. So these two diagrams here, 1, 2, who can tell me which has got the higher density? Is it diagram 1 or diagram 2? You're absolutely right. Number 1 is higher density. Number 2 is low density, because we've got more particles in a given volume here than we have over here. Okay? So this is what would happen if we heated up an object. You remember how when we heat an object up or a fluid up or a gas up, the particles have more kinetic energy and they start vibrating more, they start moving around more, taking up more space. So this hot area here actually takes up more space because the particles have more space between each other. It's not the particles that are getting bigger, it's the space between them that gets bigger. Okay, can you see by that diagram? So when fluids are heated, the particles change energy, they spread out, and this causes their density to change. Now this is important when we realise, okay, a high density object or high density bit of air or fluid will actually sink downwards. You saw in the video when the teacher put an ice cube into the liquid, you saw the food dye going down, you saw the fluid actually sinking down. But if we heat up, what happens? Lower density section of fluid or air will rise up. Okay, so the rising over the higher density, cooler fluids happens. Now this is really important when we're looking at applications of convection. This is the exciting bit of science, isn't it? The real life bit. I'll show you this image here. Everybody's seen hot air balloons, right? A hot air balloon, see these arrows here? Inside the hot air balloon there is a big flame, and you can turn it on, you can heat all of the gas inside the hot air balloon. So all the particles inside the hot air balloon move further apart. As they move further apart, they take up more volume, they become less dense. Yes, and they become less dense than the air outside of the balloon. Now, this is the really important bit. Hang on, let me get my inking. There we go. Now, if I was to draw the particles outside, maybe it's a really cold day, the particles are very densely packed together outside. Just imagine each one of those is a particle. Won't do the whole thing. But can you see outside the balloon we have higher density air? So what's going to happen to the hot air balloon if the air inside is less dense than the air outside? You're right, it's going to rise, isn't it? We've just seen down here, low density rises. So the balloon is lower density than the air around it. It will rise until it becomes the same density as the air surrounding it, and then it will just stay where it is. So that's a really cool application of convection, or using convection currents. And there's lots and lots of other applications of convection currents. We use convection currents in colder countries here. So this radiator in colder countries like the UK, Scotland, Canada will actually heat up the air here. The particles of air will heat up, they'll become spaced out, they will actually rise up over the more dense area that surrounds the radiator. Imagine all the air is colder here, so this air rises up, hits the ceiling, moves across, and starts circulating around the room again, because as this air rises, air has to replace the air that's lost here. So as this rises up, cold air is drawn in, which again gets heated by the radiator, which rises up, which goes to the ceiling, circulates around, and we can heat up the whole room like this just by using one radiator and using convection currents to help us. So pause the video whenever you like, make those notes, draw the diagrams. This is a great diagram to draw as well, an application of convection currents, as is the hot air balloon too. Okay, I hope that helps. I'll speak to you in a minute. Thank you.